Now let's load up an actual reconstruction project to show you how everything works in practice. I'm going to go to my directory and load up this project called Block D. And again, each project file is actually an XML file that can be edited for later on. And this file contains links to the file names of our images and any additional metadata that we store for those images, such as slice thickness, voxel sizes, and segmentations. This is a project with approximately 30 slides, so it takes a moment to open. Since each slide is about 1 GB in size, we don't actually load each one into memory. Rather, we load downsampled versions of the slides into memory, and as the user zooms in, we load small chunks or tiles of each slide on demand. This allows us to concurrently view many slides while not taking up all of the user's memory. Okay, so here is our slide stack. Bear with me for just one moment. I'm going to hide all of the segmentation labels. And I'm going to open up our reference image dialog and show the reference image. There it is. And okay, so you'll see that this project has 33 slides, numbered from 0 to 32, 0 being the slide closest to us, and as we increase the index of the slide, we've moved farther and farther into the view plane. You can see on the orthogonal views here, with the yellow crosshairs, that as I change the currently active slide, the crosshairs update to match that slide. Now this is a little bit confusing because I have a lot of slides loaded, so let's just go ahead and hide all of our slides. You can either click here on the Hide All Slides menu item or hit Option W to hide all slides. So now all that we have visible is the MRI image. One feature that I did not show in last video was this window level feature, so we can actually go and window and level our MRI directly in HistoloZee to bring out whatever features we want to see. Okay, so let's load up slides sort of halfway in the middle of the stack here and zoom in. A couple important things, just to recap. When I zoom into the orthogonal view, you'll see that the currently active slide, i.e. the one that transformations are applying to, and the one whose data view and transform parameters are being shown, is highlighted in blue here. That just happens to correspond to the color of the slide's border. So we can change the color of that slide's border to the tangerine, and then that color changes to tangerine. I'm going to turn on edges for this slide just to show you what's happening below it. As I scroll within that slide, you can see that the MRI changes, but the slide does not. If I want to select a different slide in the stack, I can simply right-click on that slide on the stack on the right side, or I can click on that slide on the slide sorter view, and everything is updated in real time. So I am clicking on those slides in the slide sorter view, but you'll notice that no slides actually appear in the slice view. That's because they've all been hidden, they're all invisible. All you have to do is click on the checkbox or hit W on the keypad to show the slice. However, since clicking on a slice updates the crosshair locations in 3 dimensions, the MRI will naturally redisplay itself to show the slice of the MRI at that location. And again, we can fix zooming in horizontal and vertical directions in the orthogonal views, or we can choose to not keep horizontal vertical aspect ratios. This is handy for viewing all the slides in a stack. The origin of the stack, i.e. the k equals 0 index location, is at the very top here. So let's click on this slide here and view it. You'll notice that this slide has quite a big spacing between itself and the one that comes before it. How do we do this? Well, there are two ways. If you know beforehand that your histologist advanced the tissue during microtoming, you can actually type in the known spacing of the slide. Here I've selected 0.8 millimeters for the spacing. You can change that to 0.0 or 0.6 or 0.8 like we had, and everything gets updated in real time. You can also go to the Transformations tab and either manually apply a transformation into another plane, like this. This brings the whole stack up and down. Or you can choose automatic registration with the stack shift parameter included as a degree of freedom when registering histology slide to reference image. And this will try to optimize over that slice, that stack shift parameter. You can advance through all the slides in your stack using these arrows here. Or using the keypad, Command square bracket. I'll bring your attention here to these two special slices. You'll notice that most of our slices are stained with Kluver-Barrera, which is Missile for neuronal bodies. Sorry, Missile for white matter and myelin. And cell bodies are dark purple. We also have another stain. In this case, we've stained for A beta protein, and another stain is for tau protein. So all of your extra stains can be included within the slide stack. And if you do not want those to modify or to affect any of the other slide transformations, you can simply go to those slides under the Data tab and select 0 thickness for those slides. And you can see here in the orthogonal views that those slides, in fact, have 0 thickness. So let's just view one of these slides. And you can begin to appreciate the beauty in this tool when we try to examine histology and MRI together. So now I can go into the, say, pyramidal layer of this histology slide, and following alignment, look directly at the MRI that's below it. And there it is. You can appreciate just how coarse the MRI resolution is. Within each of our 0.2 by 0.2 by 0.2 isotropic voxels, we have quite a number of pyramidal neurons. And of course, we can refine this registration. We can rotate. And we can even do automatic histology slide to reference image registration, even with that extra slice parameter. So I'm going to run that right now. Keep your eye over here on this slice over here. I'm going to change the color to make it red so it shows up better. Keep your eye on that slice. let us put back the similarity metric, change it to neutral information, turn off masking, and run registration. Now you'll see that it attempts to automatically align the histology slide to the MRI image using additional out-of-plane translations. Now, you can also register the reference image to the entire slide stack with this option. For now, for simplicity, let's choose isotropic scaling as our transformation. And what we'll do now is align the MRI image to all currently visible histology slides in our stack. So let's make all slides visible, show all slides. This metric here is the joint histogram between each of our slides and our MRI image. If I click Run Registration now, you can see that our MRI image is being aligned in real time to the histology stack. And again, this feature is currently in development. It isn't perfect right now, and it's probably never going to be perfect, but it is a handy way to sort of roughly align all images together before doing manual fine-tuning. So let's just wait for it to keep going until it ends. And you can see, of course, that all of our transformation parameters update in real time in this property dialog. And there you have it. So now, hiding all the slides, let's click on just one of the slides, you can see that registration is pretty decent between each slide and that reference image. Of course, we can threshold out the background. And there it is.